Hello, and welcome to a fully live and unexpected episode of Hacking with Friends. My name is Kody Kinzie. I am a security researcher at Varonis, and my camera is not here, as you might tell, but we're going to do it anyway. And I have my good friend Angelina Tsuboi here today to talk a little bit about some projects she's been working on. Angelina, thank you for joining us from quite a fancy location.
Yeah, thank you so much for having me here today, Kody. It's a great opportunity to be live with you. And yeah, hi everybody. I hope you guys are all having a great day so far.
So thank you for joining us from like a park. It looks lovely. It looks lovely over there. I am joining from Los Angeles, where I am visiting, and we're going to be trying out with some new streaming gear pretty soon, but not quite yet. So please excuse the lateness in the stream today. We really had to kind of improvise things, but like it happens. So good to see everybody. I also noticed that I scheduled the stream for tomorrow instead of today, but I fixed that, so we should be good now. So I want to, as I have been usually, give a shout out to our Discord server as well. I've seen a lot of great people active there, asking questions and otherwise, letting us know that they are active. In fact, I was able to let James know that I messed up the stream scheduling today. Thank you for letting me know on that. So if you have any questions while we are live, feel free to either jump to the live chat on our Discord server or leave a live Q&A question where I can go through and answer them. And as you can see, there's some questions in here that I'm going to answer. But first, James, before I answer your very excellent question, we're going to talk a little bit with Angelina about what you have been working on recently. And you have been working on a ton of stuff. You've been working on Nugget related stuff, and you've also been working on some OSINT stuff and signals intelligence stuff. So, what is it that ties this all together for you? Like, is there anything that all these projects have in common that make you interested in these sorts of things?
Yeah, I think curiosity is the main driver behind all of my projects. Whenever I want to learn something new, whether it's like cybersecurity related or computer science related, the best way for me to learn is by working on projects, whether that's like personal research I want to conduct or like making an OSINT tool. So I really enjoy working on cybersecurity related projects, and I think it's a great way to learn new concepts that I'm curious about.
Hmm. So you have a number of different skills, both front end and back end skills. And usually hackers will kind of pick one or the other, but you have a pretty good talent for both. I think you've designed like a good amount of like user interfaces for projects you've worked on. And that's given you a pretty unique experience. So one of the things, also Leo's mentioning your audio is a little bit low. So yeah, so if you lean forward or I guess shout, you're in the woods anyway, so who's going to hear? It might help. But because you have good experience with making some of these tools on the back end and good experience making tools on the front end for people to use, do you want to talk a little bit about the nugget.dev design, which I will pull up on my screen?
Yeah, I would
Here
love
we
to
go.
talk about that.
All right, we have it up. And right now it seems like, let's see. There we go. If I enlarge it, that little white bar goes away. But this is something. Well, actually, I'll let you explain it. What was your goal in designing this website?
Yeah, so the Nugget.dev website is essentially like a repository of all the links and documentation a beginner would need to get started with the project um, and learn more about what the Nugget does and get started with development with it. And the main goal I had for this website was to make it really simple and intuitive so that a beginner who's like really new to cybersecurity can get started right away and like know what they're doing. Um, there's like this design philosophy I follow with that adheres to simplicity and um, the intuition of the user. My goal with design, and especially with front end design, is to make it as simple as possible. So there needs to be no instructions on how the user could get started. The user can automatically just like follow through the structure of the website, and it's just really intuitive from the get go. I think that's really beneficial, especially for new people that are getting into the Nugget and want to learn about what the Nugget is, because it really reduces the barrier to entry from about learning about the product. And I think being able to like empathize with the user and like really like pinpoint what struggles they might have in a website and to make it simple and as basic as possible is really beneficial, especially with user experience design.
So let's give it a spin. I think that what's cool about this is the number one thing, selling these nuggets that we get asked is how do I tell the difference between a Wi-Fi nugget and a USB nugget? Because different projects run on each one. They both have a different microcontroller. And for people that are just getting started, not knowing which one you have or not knowing which projects go on it is probably the most confusing thing, So we very helpfully made this little comparison so you can kind of see the difference between like the nuggets and which projects run on them. But not everybody wants to look at this graphic. There's some people who would rather. I think I need to move this over there so we can see it. There we go. There's some people who would much rather just plug it in and have it automatically like show you what you can run on it. And that is actually exactly what you did. Like you solved the problem of having to know which one of these you have, because when you plug it in theory anyway, it should be able to automatically identify itself and give you a list of all the different projects that are supported on that particular device, which is fantastic. That really like takes the guesswork out of not knowing what nugget I have. So in my hands, let me self-produce this stream. All right, so in my hands, I have two nuggets. One of them is a USB nugget and one of them is a Wi-Fi nugget. I don't know which is which, if I'm the customer. I do, because secretly I can turn them around and check and identify them from the back. But on this one, I'm going to say I don't know which one this is. I want to plug it in and I want to do something cool with this. Like that's it. So I'm going to plug it into my computer, and I'm also going to cross my fingers, because anytime I do this on the stream, I risk disrupting everything. Okay, it's plugged in and the stream's still working. Okay, that's good. I'm going to turn this back on. So I'm going to, okay, so Roman says, is this like a YubiKey? Sorry, new question. No, so this is not exactly like a YubiKey. This is like a little hacking tool that allows you to harness the power of these microcontrollers and break them out into a form factor that's really easy to use. So the one thing that these microcontrollers don't have is a screen, buttons, like anything to really make them like useful for the average person without plugging it into a computer first and then doing some command line stuff. So one of the things our team has done is basically pick these really popular microcontrollers that hackers love and then build a little like shell around them, or like an add-on board that makes them easier to use for beginners or people who want to try these one-off projects that are really fun to do and really like kind of straightforward. So, okay. So that being said, we have one of these. We don't know which one yet. I'm going to click on connect your nugget. I can see that this is the correct serial device. And this is, again, all from the Chrome browser. And I can see, oh, it's a Wi-Fi nugget. Cool. So we've automatically identified our nugget. And let's say that I already have something flashed to this and I've already done this. I want to just get started and like connect and interact with the device. I can click on the serial terminal, connect the nugget. And then I'm very nervous, Angelina. This is getting into my furthest goals. I'm going to type help. Oops, there we go. Type help, click send. And it looks like maybe there's nothing on this nugget, we don't get anything back. But in theory, if this was flashed with something, then we would be able to like hear something echo back. So, all right, let's go back to the flasher. I'm going to refresh. Connect. Okay, so taking notes, getting back to the flasher here seems to.
I think you need to go back to the nugget.dev page.
There we go. All right, so starting back, we're going to connect our Wi-Fi nugget. We're going to erase anything that's on it right now. And then we have a list of different projects that are supported for the Wi-Fi nugget. These are open source projects that are like MicroPython, for example, is a project that is freely available for anyone. And there's actually a build specifically for the microcontroller that's at the core of this device. So that makes it really easy to install and use. But we also have DAuth detector, the Nugget DAuther, and then the more advanced ESP8266 DAuther, which let's pick the advanced one. I'm going to click program. And Angelina, thank you so much for adding this progress loader bar. In the previous version of this, we didn't have it. And I was always like inspecting the element to get like a percentage and like watching it go up so I would know how much time I had left.
Yeah, I think the visual
Yes,
indicator
James.
is great.
Yes, James, we are in fact live today. Sorry about that. I accidentally apparently scheduled it for tomorrow, even though that was definitely not the case. All right, so another question. So it's a web-based Wi-Fi attacker. Sort of. So this is a web-based interface for interacting with either one of these devices. So when we have a lot going on these little microcontrollers, they often don't have the leftover power to do things like offer up a web interface or something fancy. So instead, we can connect to them directly via Google Chrome. And Angelina's website here allows us to both flash new projects to it and also then connect to it and run those projects in a serial terminal, all without having to pop open a command line terminal or anything outside of the Chrome window. Okay, so it says that this is done. To run the device, please reset. So in order to reset, I'm just going to unplug it and plug it back in. It's the easiest way to do it. And now my Nugget should be flashed with a new project. So I'm going to try to go to the serial terminal. Okay, that worked. Cool. And then I'm going to type help, see if anything happens. Whoa, a bunch of stuff happened. All right, cool. So we're still working on getting the formatting right, but we can see that we got the help menu for the ESP8266 deauthor. And if I were to use like a different serial terminal, I believe like this would be, outputting correctly. So the flashing worked. We just are still in the final phases of figuring out how to get the output here to look nice and clean. So Angelina, is that the way, is that roughly the way that you're kind of imagining a user who has one of these two products is able to then plug it in and just get started working with it?
Yeah, that was the main goal. When I first started this project, I wanted to make it as easy as possible. So like one click and then boom, you're directly into the serial terminal or the flasher.
Yeah, that's super cool. I'm really pleased with how this came out. And I'm not the only one who thinks that. I'm really pleased with how this came out. And let's go ahead and let's try the other thing then. Let's try this USB nugget and see if the process is similar. So the only difference in flashing the USB nugget is the ESP32S2 requires for us to hold down a flashing button. So where's that graphic? So on the back here, you can kind of barely see it. Maybe I can make it bigger. Let's see. Yes, hooray. Okay, so on the back of this microcontroller here, we have a reset button on our Wi-Fi nugget, and that's for basically restarting the device, but there's no flashing button. We were able to flash it just through software without putting it in a special mode. The USB nugget is different. We have a reset button and then a zero button, and this zero button is something that will put it into a flashing mode that makes it possible to flash a new program. And it's just something that's required by this setup that the development board has laid out. So I'm going to press down this button. I have a version. I'm very proud of this. So after working with these for a very long time, I got sick and tired of having to take this out of the case to flash a new program to it. So I made this little button on the back here that you can press in order to flash it and get it to do something else. So I just don't want to break my Nugget. So that's why it's nice to have that little button. All right, I'm going to plug this in. And Angelina, let's see if our other flow works. So while I'm getting this set up, what do you think was, for a beginner anyway, the most relevant skill to have to build something like this? Or because you seem to do a lot of both front end and back end stuff, and I'm curious which was more useful for you in this project.
Yeah, honestly, it was a little bit of both, because in order to interface with electronics from the web, you need to have a deep understanding of how serial communication works within your browser. So the initial step of building the site was doing a lot of research, especially within Chrome's documentation, looking into how I could communicate with the ESP32 or the ESP8266, and then just engineering the functionality behind that. So whenever I'm developing any kind of website, I try to get the bare bones functionality down first. I don't really care about what the website looks like. It can look like trash, it can just have like a bunch of buttons in it. If it works, I'm happy. So first, I just focus on the engineering aspect, make sure it's actually functional, and then after that, you like embellish it by adding the colors, by adding your own design. Yeah, so like since design, web design is a little bit easier than the engineering, I just try to focus on the functionality of it first, so I don't have like other code distracting me. And then once you get the functionality down, you add the design and your own polish to it.
Cool. All right, let's go ahead and pop this open again. I've skipped ahead a little bit, so let me restart. So I've plugged in my USB Nugget. I'm going to click on Connect Your Nugget, and I'm then going to select the new serial device. It opens, I've auto-detected it. I can click on Erase to get rid of anything that's on there, and then I can see we've got the USB Nugget OS, which is what our team primarily focuses on developing. This is a human interface device, attack platform that allows you to make keystroke injection attacks using our language cat scratch. We've got a packet monitor, and then we've got CircuitPython. So let's go ahead and do CircuitPython. Yeah, let's do the USB Nugget actually. So I'm going to click program, should be as simple as that. It's going to go ahead and crawl along and eventually flash this, and then I should be able to unplug it, plug it back in, and it should work just fine. So that was so short. Like, yes, and I know that our audio is not perfect today. Sorry
I
about
think I
that.
fixed it. Is it?
Okay.
Is this a little bit better?
Cool. Yeah. Yes.
Awesome.
If anybody can, well, it sounds better for me. But if the audience can let us know if it sounds a little bit better, that would be great. But we are truly roughing it today. So just glad that we can have some interesting guests on the show, even if our audio is lacking a little bit on this one. Okay. Cool. So it is apparently a little bit better. Thanks, Angelina. Ooh, okay, cool. So this is now done flashing. I'm going to unplug it and plug it back in. And let's see what happens. So the other thing I did yesterday, okay, cool. It has successfully flashed. So the other thing I did yesterday was I had a bunch of nuggets that I couldn't figure out what was wrong with them and why they weren't flashing right. And I just threw them in my bag. I was like, I'll figure it out later, and mix them with my test nuggets. So I think I sent you a bunch of bug reports yesterday where I was like, it's not working. And then I quickly found out that I did that to myself. So that was my bad. But yeah, so that was a pretty easy way of getting one of these devices set up with a project that's it's supported by. And part of what you had to do here was take the decision out of the customer's hands for trying to flash the wrong project to the wrong platform. Like, getting people to understand the difference between these two things is frankly like too hard sometimes, and you really solved it in an elegant way by having it automatically detect. Like, can I ask, like, how did you do that, or how does it work that it's able to differentiate between the two chips?
Yeah, so when a user connects the USB Nugget or the Wi-Fi Nugget, I have code within the website that detects details about the specific chipset, and then I use that information to make the user interface appear differently based off of the Wi-Fi Nugget and the USB Nugget. And also, if anybody wants to access that graphic on the website, if you go to the website, you can click, go to the main page, click Nugget documentation, and then the link at the bottom where it says click here, you can access the graphic that way.
That's beautiful. I didn't know that you linked that up there. That's really wonderful. Yeah. That's a nice little Easter egg. Thank you for doing that.
Yeah, of course.
Cool. So this is not the only thing that you have worked on. You have also worked on some other stuff as well. Do you want to talk about a little your OSINT projects that you've been working on?
Yeah, so recently I've been getting more into aerospace cybersecurity. I think there's a huge demand for that field, and it's like an intersection between two of my passions. I really enjoy like anything aerospace related, so like aviation, aeronautics, aerospace engineering. I have a huge, deep love for, and I also really enjoy cybersecurity. So I wanted to pursue a project that kind of like merged the two fields together. So I was looking a little bit into satellites because satellites are cool to hack, and I I found like a couple of like data sets for satellites, but it was like really unintuitive to scroll through, and I was like, like why can't I just make an OSINT tool that makes it really easy for like a researcher or a hacker or a security researcher to find information about satellites and where they're positioned, data about it, um, and make predictions about when it's gonna like pass through them um, in the sky.
Sorry, I thought that they were coming for you. It sounded like the whole SWAT team was like arriving at your location. Um, so I pulled up your project. And by the way, I have to say the mark of like a good hacker project is the ASCII art, and I think you really nailed it here.
Oh yeah, I spent so much time on it. I spent like 2 hours perfecting the ASCII art for this project, and I'm pretty happy with it. The satellite looks cool.
Yeah, no, I agree. And like I immediately understood like what it was supposed to be. I
Yeah.
thought it was very, very clever. So all right. So you made this in Golang. What made you pick that language?
Yeah, so I know a lot of programming languages, but the two main ones I use now for cybersecurity development was Python and Golang. Before this project, I didn't know Golang, so I decided to learn Golang mostly because I know a person in the field who's also really like talented in cybersecurity, and he made most of his programs using the programming language Golang. So and he was like really incessant about me learning it as well. So I was like, okay, I'll give it a shot. So I decided to embark on the journey of learning Golang. I taught myself it in about an hour or so. And then I was like, okay, I'll just apply um, my new knowledge of the programming language to build an OSINT tool like this. And
I love that.
and I've built like previous cybersecurity related projects before using Python. The main advantage I see of using Golang over Python is performance. It's a little bit faster, although the learning curve is a little bit steeper for Golang. It's faster as concurrency support. There's like a wide range of reasons of why Golang is great for development. I'm loving the language so far.
Hmm. Wow, okay, that's really cool. I hadn't honestly heard a lot about it. I just see that there's some like threat actors who are now like using it to write tools in. But that's really cool because actually what I did was as soon as I learned Python, I was like, okay, that's cool. Like I know how to use this in general now, but like give me real data, like give me something that's actually like
Yeah.
interesting or fun. So the first thing I did was I made a satellite tracker well, actually no, I made an ISS tracker that would tell me like how many people were in space and who they were at any given moment. And it was fun. It was like a great way of testing out the language and being able to make something useful for it. So it's really cool that you did something that is genuinely useful, that plugs into probably like I'm assuming like APIs in order to figure out and process data in a cool and hacker centric way. What kind of data sources did you zero in on for this project?
Yeah, so I used two main API sources to do this project. One was SpaceTrack, which provides like a large data set of satellites, and then the other is N2YO, which is more geared for orbital predictions about satellites, so visual passes and radio pass predictions.
So one question from the audience is, do we need specific hardware to test this project?
Um, No, as long as you have a computer with an operating system that supports Golang, most do nowadays, you can pretty much run this on any device. All you have to do is like
Cool.
download the code from GitHub and then run it.
And could you also run this on like Google Cloud Shell or like some other like free like VPS?
Yeah.
Cool. Yeah. So you don't even need your own computer. You just need a window into someone else's, and you could try this out. Um, so here's a question I have is when I'm working on these sorts of projects, I'm always looking for good data sources to like add to my script or to be able to do that. And I look in all sorts of unusual places. I'll look in like state databases for APIs. I'll look for at like data.gov, like to try to find APIs. Where did you find your databases in this case, like for this project, or how would you like recommend a new person start looking for data if they wanted to make a similar project?
Ooh, okay. I really like that question. Yeah, so first, I would recommend doing research. So just like a general Google search, just to get like a brief like overview of the data sources out there you could use. And then from there, what I do is I look for similar, not like exact projects on GitHub. So like
Mm.
see what like APIs other people are using for their own projects. It doesn't have to be like in the same programming language you're using. Just like you just need to look for the API link reference. And yeah, and I see like which one's the most popular and the most credible, and then I just basically like rank it off of credibility from there and pick the 2 or like 3 best sources of data.
Do you think it's is it time consuming to figure out how to like use the API and like pull in the data and sanitize it so that it works with the rest of
Yeah.
your stuff?
Yeah. Yeah. Another thing I also look for when I'm looking for APIs to use is how good and polished their documentation is. If their documentation isn't very thorough, that probably means they didn't have a lot of great developers working on the project. Sometimes like they do, but like if you're a good developer, you should put in time like documenting your code. So yeah, like these 2 API sources I used for this project, it was really, really easy to hook up and implement because the documentation was so simple, and like they provided like written examples of it as well.
Cool. So in order to follow along with this, it looks like we need to make an account at SpaceTrack, save the username and password, and
Mhm.
create an account at N2YO and save the API key. So it looks like this service is you're able to retrieve stuff just with the username and password token, and then this one you have to actually have to generate your own API key and stick it in. Update main.go to have proper credentials. So you put the API key in here, you
Yeah.
put the SpaceTrack information here, and then you export the module, and then you can run it, and it works.
Yep.
So
Yep.
Go is compiled. Is that, I don't know if that's a dumb question.
Yeah. So essentially, what those lines of code are doing is that it's like turning on the module settings, and then it installs all the dependencies for the project, so you can
Okay.
run it.
Okay. So it is compile. Is it compiling it? I know very little about Go.
Yeah, so Go, the second line that just installs all the dependencies, and then the last line would compile it and then run the code.
Okay. Yeah. So
Yeah.
I just like, I'm coming from like Python or C++. So in my head, it's either, it's either like compiled or it's interpreted.
Yeah.
All right, cool. So after we put in the information, we compile it, we run it. You document the APIs used. That's cool. I'm gonna check one of them out actually, just because I want to see. Cool. All right. So this is one of the data sources you use. This is the other data source you use. Cool. These websites look like they were designed in like the late 90s. So I
Yeah.
imagine they have all sorts of great data.
Yeah.
All right.
Pretty
That's
great.
cool. That's cool. So did you want to show off what using this tool looks like?
Yeah, sure. I'll share my screen in a second here.
I have stopped sharing my own screen.
Okay, sounds good. All right, can you guys see it?
You will in 3, 2. Yep, there you go. And just try
All
to enlarge it as big as you can.
right. Okay. Yeah, so
Yeah,
this is
cool.
a demo I pre-recorded a little bit earlier today. Yeah, so when you execute the project, this is like the display banner that pops up. I really like the gradient I put in it. I think it's a nice like additional touch to everything. And then
It's pretty.
yeah, it's pretty good. And then below it lists the set of features the tool has, and you can just put in the number input corresponding to each feature. So in this example, I run the orbital element data display, and then when you run that, you can select from a list of satellites, and that returns information about the satellite, that's contained. This is like pretty much standardized information that's contained and retrieved from satellite data sets. So it would be like the name of the satellite, the catalog number, the designator, which is used to like identify the satellite, the epoch, and just like general information about the telemetry of the satellite and where it's located in space. The second feature of the project is the telemetry display. And for this one, you can input a custom NORAD catalog ID. And what the NORAD catalog ID is, it's a unique ID that's used to identify each satellite in the sky. So for this example, I use the ID 25544, which is the designator for the International Space Station. And then from there, you can put in your latitude and your longitude. I used a fake latitude and longitude for this one, so I don't reveal my location, but you can see what that returns is just general information about the satellites. In this case, it would be the ISS, and then positions that it has assumed over time. So it revealed like the latitude, the longitude, the altitude, the right ascension, and the satellite declination. The ascension and the declination is like GPS, but in space, which I didn't know. So like in space, they use a different geo-coordinate system than on Earth. So that's what that means.
James says that you are smart for pre-recording the demo and that you are refusing to feed the demo gods today.
Yeah, I just risk management. I didn't want to risk it today. Yeah, so.
Yes, he also is congratulating you for not leaking any personal information by not only sanitizing it from your data set, but also streaming from a park.
Yeah, I'm being extra safe today. Yeah, so another feature that's included with this tool is orbital predictions. So there's two types of orbital predictions. There's visual and there's radio. Visual predictions is when you're predicting a satellite to pass an orbit over you, so you can actually visually see it. And then radio is when like radio receivers can actually recognize when the satellite is passing over you in the sky. So for this, you just need the NORAD ID designator, the latitude, the longitude, your altitude, days of prediction, and visibility. And by inputting all that information, you get a long list of predictions or satellite passes with data associated for each satellite. And then the last feature I added was like a quick little TLE parser. What a TLE parser is that it's kind of like a program that parses for satellite or like any information about like a payload in space. Whenever you deploy an object into space, information about that object is sent back within a standardized format called TLEs, or like two set line elements. And it's like a data format that includes information about the telemetry of the object in space. And usually it's like a pain to look at because it's like this long list. I show it here in the demo. It's like a really egregious list of numbers. Yeah, like by looking at that, I can't tell what it's saying. So I made like a quick little tool in the end that translates all that information into a recognizable format, which I thought was a nice touch.
So if somebody wants to use this themselves, they would go to the GitHub repository, download it onto their own system or onto something like Google Cloud Shell, and then compile it and run it. And they should be able then to make queries about objects in space and all sorts of other cool stuff, right?
Yeah.
Okay, that is awesome. So I know we've got about 10 minutes left, and that's not all. Like that's not all you've been working on. You also had this article come out on doing drone reverse engineering using packet dissection and Wireshark. So basically, like trying to figure out what sorts of information a drone is sending.
Yeah.
Can you talk a little bit about your experience here?
Yeah. So recently with my like newfound obsession of aerospace cybersecurity, I was just like, I'm on this project to like hack everything that's like tangentially aerospace related. So part two of that series or that saga is drones. And the reason why I picked drones was I had access to a DJI Mini 2 that I got about like a year ago, and I wasn't really doing much with it. It was just like lying around. So I was like, okay, I want to use a tool that I'm familiar with, which was Wireshark, and try to figure out what information I could figure out about this drone's communication protocols. Um, so what I did was I used a couple of like reverse engineering techniques, like packet dissection and comparing the bytes retrieved from payloads within packets that are sent between the DJI drone's controller and the aircraft itself. Um, so the way I configured it was I created like an access point. So I configured a man in a middle kind of configuration where it eavesdrops between packets of data that are transmitted um, between the DJI drone controller and the aircraft itself. And I was just like analyzing the information that Wireshark was capturing. And I was able to figure out a couple of things from it. So DJI packets of information used within their communication protocols, they are encrypted, but not really. And what I mean by that is that you can find patterns within the packets of data that are being sent. And to do this, I used a large data set of previously known like DJI packets of data, which is like bytes. And then I used byte comparison between packets to figure out what the drone protocol, communication protocol, was doing.
Hmm. So you were able to look at kind of like I guess I would call it like almost like metadata then of what it was sending.
Yeah, pretty much, and like instructions the controller was sending to the drone.
Hmm. So I guess my biggest okay, so one question from James is, does that drone only use Wi-Fi for communication?
Ooh. I think it uses radio as well. The way I was able to do it is because since on the DJI Mini 2, you use the DJI Go Fly app
Hmm.
to like control and fly the drone. It uses Wi-Fi to communicate to the drone. So I just intercepted that data. Um, and
Okay,
that's on
okay.
the
And
2.4. Yeah.
how did you set I'm just curious, how did you set up the man in the middle thing? Like how did you make
Yeah.
it so that it was actually like connecting to you rather than the controller?
Yeah. So I had another machine open and I ran this create AP. It's like this long um, line of code. I think I put near the bottom of the article. Um, but there's essentially there's a command line tool you could use called create underscore AP, and that creates like an access point. And I just put that in between the communication from the DJI Go Fly app and the drone itself to intercept communications.
That's really cool. All right, so I have it pulled up. Yeah, so I see like sudo create AP WLAN0 operator, blah 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 blah, and then all that stuff. So wow, that's really cool. That's really really cool. Uh, sorry, I'm just like reading through it now. Wow, so this was a pretty extensive project, and it's funny because my friend Brian and I also took a stab at analyzing these sorts of communications, but we were using like a Hack RF1, and like we were really like like kind of like bringing a lot of gear to it. This is just what did you use to do this? Like a wireless network adapter?
Yeah, that was pretty much it. Yeah, a wireless network adapter, um, and Wireshark.
That's so cool. So if you are someone who's interested in aerospace, then I imagine Angelina would be someone you probably want to follow. We've got like 4 or 5 minutes left. So Angelina, where would be the best place for people to follow you if they want to keep up with your projects?
Yeah, I kind of post my projects all over the place. I've been pretty like rigorous about that lately, so I post updates on like Twitter, and LinkedIn. I also make posts on like Hackaday, Medium, and Hackster.io. If you just want to find general information about my accounts and where to find me online, I would recommend going to my website, which is just my name, angelinatsuboi.net. That includes all the information about previous projects I've done in the past, and what I'm up to.
Um, Sorry, the URL was .net.
Yeah,
That's so cool. I really like .nets.
yeah.
Okay, and I have that up on my screen. So if you are wandering on the internet and you're looking for the correct place to follow Angelina, oh yeah, all your socials are right here. That's perfect. That's great. So um, very, very cool. Well, first, thank you. Whoa. Um, Somebody is demanding to know about the tsunami detection buoy. Okay.
Yeah, yeah. So one of the most ambitious projects I'm working on right now is a tsunami detection buoy. That's low cost and accessible. The problem with current tsunami detection systems is that they're super expensive. They're like hundreds of thousands of dollars to maintain a year, and most tsunami detection buoys they fail within 1 year of maintenance, and they need like extensive maintenance fees. They're super expensive, and it's inaccessible to like researchers that are not within like privileged areas. Like low income researchers can't really conduct tsunami detection research because of that. So um, one project I'm working on right now is this tsunami buoy prototype, which I'm planning on making to be less than $200, which conducts research about tsunamis. So it gathers telemetry information and uses that information in conjunction with artificial intelligence to detect for tsunamis.
That's so cool. I thought for a second I thought they were like doing like a play on your name or something, and I was like, haha, that's funny, but no, it's literally a tsunami buoy. Okay, cool.
No,
Um,
the initial name idea I had for it was the Tsubui.
I like that a lot. I like that a lot. So James was also mentioning that GPS is also another cool avenue of attack on drones, but you actually have been doing some research not just on this, but on ADSB and some other things that could be used to do some interesting spoofing on drones and also probably planes, right?
Yeah, yeah. In regards to the plane one project I've been working on recently is a ADSB spoof detector, and what ADSB is, it's like a radar system to keep track of planes that are flying in the sky. And one of the it's like very commonly used. Lots of pilots I know use it. Air traffic control uses it. It's a universal standard. And but one of the main vulnerabilities of that system is that anybody could transmit information on that frequency. So it's really vulnerable to spoofing attacks. So I recently made a prototype called Flycatcher that uses a Raspberry Pi alongside an RTL SDR to track for ADSB information about planes and um, detects for spoofing attacks of planes using a artificial intelligence program I wrote.
So, yeah, I think the general consensus is that you are awesome, as
Thanks.
as someone notes. But one thing I really like about the work that you do is that you often like give back. After you accomplish something, you turn around and make it a little bit better for the people who come after you. And one of the examples I also wanted to shout out that I thought was really cool is the pilot fast track. Like this
Yeah.
is, if I remember correctly, when you told me about this, I was just like, Angelina, like, how did you become a pilot? What did you have to do? And not only did you find some very clever ways of being able to put yourself through this process, you also tried to make it easier for other people who want to do the same thing. And I think that that
Yeah.
is super cool.
Yeah. When I first started off my pilot license, I was just really overwhelmed by the cost associated with getting a private pilot license. It was like insane. It's like twenty to like $30,000 to get your PPL here in California. And I was like, there's no way I'm going to pay for that. So in order to fund the cost associated with my private pilot license, I needed to go on like this huge scholarship hunt. And I thought that process was super unintuitive and really time intensive when I could have been utilizing that time to like catch up on groundwork and learn more about aircraft theory and spending time like studying for the knowledge tests. But all that time just went down the gutter because I had to find these scholarships and apply for them. So in order to combat that problem, I made a web app called Pilot Fast Track, which is like a resource repository for aspiring aviators to find scholarships to fund their private pilot license or any like certification or rating they're pursuing. And yeah, I'm really happy with how many people have used the web app so far. I had a group of Tanzanian pilots reach out to me about this because they were apparently using it to find international scholarships, which is really heartwarming to hear. And I'm glad like people across the globe in a country I knew nothing about when I initially heard about them were using that app and finding value out of it.
Oh, sorry. I muted myself. Sorry. I was going to say, one of the things I really like about the hacker community is when we learn something or when we like go through and better ourselves, we often turn around and like make it easier for the next person to do it and kind of keep pushing each other forward. And I really like that about this project, and I really like that about a lot of your projects. So thank you for doing that. It's something that I think is a very, very um, appreciated skill in the hacker community because none of us can grow without people like you coming and making it easier to take on what seems like really big tasks, like getting a private pilot license when the cost is like $20,000 to $30,000 out of pocket.
Yeah.
Like that's pretty daunting.
Yeah. One quote I tried my best to abide by at all times that a mentor of mine told me was that you're either a maker or a taker. So um, utilizing your skill set to make something of value for other people is really meaningful. And I would say like whenever you learn something new, try to find like be perceptive about the problems within your community and try to like pinpoint one thing you can tackle and in order to contribute because you can really have a huge impact, especially with like projects like Pilot Fast Track or like anything you decide to pursue, whatever you're good at. You can have a big impact by applying your skill set to make the world a better place.
Oh yeah. So all right. Definitely check out Angelina's website if you want to stay in touch. And also, if you have more questions you want to ask, go ahead and jump on our Discord server, which I will share again in the chat, to let us know. You can ask a forum style question here and we'll get it answered so other people can find it too. Or you can also hang out in the class chat where you can, the live chat where you can find out whether or not we're actually going live today. So Angelina, thank you again for showing up and walking us through some of these projects you've done. They are pretty a pretty broad range of things, but kind of like focused, I think, around like stuff that flies. So if you're interested in stuff that flies, then hopefully people can follow you and find more interesting information they relate to. Also, per always, got to give a big shout out to our sponsor, Veronis, who lets us do this twice a week, every week. If you want to let them know that you enjoyed this, then go on over to Varonis.com/Kody, Kody, my name. And they do check this. So, the more people that go to this, the more we get to do the show. And this time we're going to be talking about DSPM. And what does that mean? That's data security posture management. There you go. And the goal here is to understand how big organizations make it so they can find data automatically and know where it lives. Frequently, when we hear about these sorts of big breaches, it's because data has kind of gone everywhere and nobody knows who has access to what. And when somebody does click on a bad link, it encrypts everything or steals everything. And as we know, you can't unbreach data. So if you're interested in learning about how emerging cloud security approaches to DSPM work, then check out this event. It's going to be Robert Blythe and Matt Radilak, both really cool speakers who I've hung out with many times at conferences. And yeah, it's going to be really fun. So thank you, Angelina. Make sure to check out the Discord server if you want to keep the conversation going after the stream. And we will see you guys again on Friday, where hopefully I will have a camera that is not attached to a MacBook Pro that is old. All right. Angelina, thanks again, and we'll see you all later. Bye.